Okay, for this assignment, you're going to be looking at 4 resistors set out in a network as in the circuit diagram, connected to a variable power supply. 3 of the resistors are of known value, 1 is unknown, although you might be able to work it out from the colour code. But your job, or my job in fact, is to use a multimeter to get a series of readings from which you can work out the value of the unknown resistor. And there they are in practice, 2 in parallel on the right and 2 in parallel, including the unknown one connected in series with it, on the left. So first of all, let's use the resistance scale to check that the parallel network on the right, those 2 resistors, gives a reduced resistance as you would expect as a parallel pair. And then the parallel pair on the left with the unknown resistor gives that value for the overall resistance of that pair. And overall, the 2 pairs in parallel connected in series give that overall resistance. From that, you should be able to predict a value for the unknown resistor. Now I'm going to connect the resistors to our power supply and see what measurements we get for the potential difference in volts, first of all over the whole circuit, and I'm going to adjust that to a value of 3 volts. And then we'll also be able to look at what the voltage is across the 2 separate parallel pairs. So first of all, let's set that to 3 volts, adjust the range on the multimeter, and therefore you have got those 2 parallel pairs, that whole resistor network, connected up to a 3 volt DC supply. How much of that potential difference is across the left-hand pair? And how much of that potential difference is across the right-hand pair? Is that what your predictions would show using calculations? You need to show me that and work out why those proportions are as they were. Let's just check that again with a higher overall voltage supply. Setting the input potential difference to exactly 12 volts. Again, what proportion is going to be over the left-hand pair and what proportion of that 12 volts over the right-hand pair. Make sure you've recorded those results. But again, in your report, you need to show whether that matches with what you would expect from calculations on resistor networks. See, very slightly out there because the input supply has increased slightly beyond 12.00 volts. So let's just check it's back on that 12.00. And the final thing I want to check, and for you to compare with theoretical predictions, is to look at the current in the circuit, for which we're going to need an ammeter, and that digital multimeter at the moment set to record the current in milliamps. And we'll actually need to break the circuit so that we can put the multimeter in series, and I'm wiring this so that it's measuring the overall current that is entering the circuit from the power supply. So again, look at the input voltage and the current. Is that what you would expect? And now, last of all, I'm going to adjust the circuit so that with that resistor there, and with a slight adjustment of the position of the wires, I'm only going to be measuring the current that is going through the unknown resistor only. So through that unknown resistor, and then the current will combine and come back through as before. But why have we got that smaller value? So there's your report. I want you to show circuit diagrams and readings, the workings to show your estimate for the value of the unknown resistor, and then a series of calculations comparing the meter readings found with what calculations would predict.